Welcome back. In this part, we are going to take a look at the GNU C compiler calling conversions, and here we are going to concentrate more on CDECL calling conversion. Okay, so we are going to use two example C functions to demonstrate how GCC implements calling conversions. Okay, so we are going to take a look at this first one. Okay, this one. Okay. This first one, it's called my function 1, and it takes in two parameters, okay, x and y, and then it returns the value from this expression, okay, and that value is an integer, okay, as you can see there. Okay, so that's the first function that we are going to be working with, and we have another function. It's right here. It's right here, and it's called my function 2, and it takes in many arguments, okay, and then it returns a value from this expression, okay, and that value is an integer, okay, as you can see right here, okay, right here. So from there, GCC does not have command line arguments, okay. It does not have command line arguments to force the default calling conversion to change from CDECL, okay, for C, okay. So they will be manually defined in the text with the directive underscore CDECL, and then underscore first call, and lastly underscore std call, okay, not single underscore but double underscores, okay, underscore CDECL, and then underscore first call, and lastly underscore std call, okay. So the first function, which is my function 1, provides the following assembly listing, okay, right here, okay. So as you can see, this is our function, my function 1, and it does some few things on the stack, okay, and with the stack like that, okay. So first of all, we can see the name decoration, okay, is the same as in CL, okay, in CL, okay, which is the Microsoft C compiler, okay. So we can also see that the rate instruction does not have an argument, as you can see right there. So the calling function is the one cleaning the stack, okay. So however, since GCC does not provide us with the variable names in the listing, okay, so we have to deduce which parameters are which, okay, as you can see right here, okay, right there, as you can see. So after the stack frame is set up on these lines, okay, after the stack frame is set up, the first instruction of the function is move L 8, move L 8, then percentage EBP, then percentage EX, okay, like this. So one will remember or learn for the first time that gas instructions have the general form instruction, then source, then destination, okay. Instruction, here the instruction, then source, and then the destination, okay, like that, okay. So we realize that the value at the offset 8, the value at the offset 8 from EBP, which is the last parameter, is pushed on the stack, is moved into into EAX, okay, like this, as you can see right here. So the LEAL instruction is a little more difficult to decipher, especially if we don't have an experience with the gas instructions, okay. So the form, which is this one, let me show you the form, which is let me try to show you here the form, this form, LEAL, that one, and then reg 1, registry 1, and then registry 2, like that, okay. This one, this dist adds the values in the parentheses together, okay, and stores the value in the dist, okay, right here, the destination here, the dist, okay. It does this, okay, it does that one, okay. So when translated into Intel syntax, we can get the instruction like this. We can get something like this, LEA, ECX, like that, and then we can have square brackets here, we can have square brackets there, and then we can have EX, then color, then pipe, okay, pipe, then EX, like that, EX, like that, okay, like that. It occurs like that, okay, so which is clearly the same as a multiplication, okay, by 2, okay. So the first value accessed must then have been the last value passed, okay, which would seem to indicate that values are passed right to left here, okay. So to prove this, we will look at the next section of the listing. So let me bring the next one. It's right here. It's right here, okay. It's right here, right there. So the value at your offset 12 from EBP is moved into EDX, okay. Is moved into EDX, okay. And EDX is then moved into EAX, okay, and EAX is then added to itself, okay, like this right here, okay, is then added to itself, okay, and then is added back to EDX, okay, as you can see right here, okay. So you remember though that EX equals 2 times EDX, so the result is EDX times 3, okay, and this is then this is then clearly the Y parameter, okay. Let me show you. So for what you saw, okay, this is clearly the Y parameter, okay, which is the farthest on the stack, okay, and was therefore the first to be pushed, okay. So CDECL then on GCC is implemented by passing arguments on the stack in the right to left order, okay, same as CL, okay, cl.exe or the Microsoft compiler, okay. So in the next part we shall take a look at the first call, okay, calling conversion in GCC, okay.